Hello, everybody. Taking a break from the How I Met Your Mother marathon that I was just watching to bring you 4.4 trigonometric functions of any angle. Very, very special. Any angle. So, what are we doing today? Evaluating trigonometric functions of any angle. Wow, who'd have thought? Finding reference angles and evaluating trigonometric functions of real numbers. Cool, let's get to it. Make this video quick. Introduction. What we are essentially doing here is mixing together the past two lessons. So we had a lesson where we were talking about the coordinate plane and relating sine, cosine, tangent in the coordinate plane. And then we had where we were doing trigonometric functions within triangles. So now we're going to mix those two ideas together. Still going by the idea, first off, that sine is related to the y and that cosine is related to the x. However, we also had this idea in the trigonometric lesson that sine was opposite over hypotenuse and that cosine was adjacent over hypotenuse. Okay, so we are blending those two things together. When we talked about just the coordinate plane before, we were only talking about a unit circle in the coordinate plane. So this r value, this radius value, never really mattered, right? Because what we were looking at before always just said sine of theta equals y over, and r was always 1 because it was a unit circle. So it never mattered before. But now we're going to input and use r values and different r values, right? So just to emphasize that point, I'm going to draw a little triangle right in here. Boop, 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 boop. I got my triangle, make it a right triangle, and I'm essentially going to be doing, this is my angle I'm talking about. I have, this side length is so much x, because it's going from the origin over so far x, and this side length is y, because it's going from the origin up so far y, because of this coordinate point y where it ends, and I have a radius of r. So, when I want sine, it is opposite over hypotenuse, y over r, that's what we're saying over here. Cosine is going to be adjacent over hypotenuse, x over r. And I'll bet you the tangent, cotangent, secant, and cosecant follow the exact same ideas. Tangent is going to be y over x, or sine over cosine. Cotangent is going to be its reciprocal, switched up. This just got flipped, so it's x over y. Secant, the reciprocal of the cosine, and cosecant, the reciprocal of sine. So that's what we're working with here. And it's important to keep in mind that this r value can never equal 0. Otherwise, this distance wouldn't exist. It would just be a dot at the origin. So because that r value is never going to be 0, these function values exist all of the time for any values of theta. So let's jump right into it and start using it. It's going to make more sense if it doesn't already once we are kind of in the middle of it. I'm going to go to red here because I feel like red really pops. I like red. I'm going to go ahead and I'm going to make my triangle because it makes me able to visualize. I like to visualize things. Right triangle. All right, now I'm going to kind of introduce something that we're not quite at yet. I think it's like 2 slides from now. It's this idea of reference angles. Because I drew this triangle here, I kind of am already jumping ahead to reference angles because the triangle really is talking about this angle right in here, even though this is the one I'm concerning myself with, this larger obtuse angle. When I make the triangle, I'm actually looking at this more acute angle on the inside, and everything that I'm basing myself off of is going to be based off of this angle. So my side lengths, I have -3 down at the bottom. I have 4 over here because it's going up 4 and over 3. And now I just need hypotenuse, the r value, which is going to be -3 squared plus 4 squared. And then I'm going to go ahead and take the square root of that afterwards because that's going to equal c squared. So, very nice. I get 25 over here is c squared. 5 equals c. You might have known that already because it's a 3, 4, 5 triangle, but never hurts to do out all the work. So, what is it I'm trying to do? Find sine, cosine, and tangent of this angle. Well, if I fill in my sine, cosine and tangent based upon what I know. I know that sine is related to the y, cosine is related to the x, and I know tangent is supposed to be y over x. But now I need to add in this new idea because I'm not talking about a unit circle. It is opposite over hypotenuse over r. And this is adjacent over hypotenuse over r. Now let's start putting in some actual numbers here. This is going to be 4 over 5. And this is going to be 3 over 5. And remember the 3 is negative. And then y over x is going to be 4 over 3. And remember the 3 is negative. Alrighty. So, back to what I was talking about before with the reference angle. What we have here is, this is the angle I was concerning myself with. However, this angle on the inside of the triangle has all of the exact same sine, cosine, and tangent values as this larger one because they are supplements to each other. Okay, whether something is a supplement or a complement, they're going to have reference to each other. Let's see. I always forget that I have all of this extra space to do work, but I jam it all onto one page. Let's talk a little bit about the signs for the sine, cosine, and tangent that we just looked at, because there was a negative number in there, and that changed some things. Now, if I was looking at this particular triangle, and I was talking about triangles, I would not have a negative 3 here. This would be a positive 3, because I can't have a negative length of a side. So this would have ended up being 4 over 5, positive 3 over 5, positive 4 over 3. All those values would have been positive. But I could come to this little nifty chart that I have over here, which tells me the sign of the sine, cosine, and tangent functions are going to be in each quadrant. And this might seem like, oh goodness, this is such complicated stuff. How do they even know that the sinus is positive here, but it's negative over here? Well, it's a lot simpler than it actually looks, because we keep saying sine is related to the y, cosine is related to the x. So if we just think about it that way, y values are positive all up here. So sine values should be positive all up here. Sine is positive, sine is positive. Y values are negative all down here. So the sine values are negative all down here. Coolio. Now let's look at cosine. Cosine values are related to the x, and x values are positive on this side. So that should be positive, and that should be positive, and they are. I don't know what I just did there. And cosine values are negative on this side. So cosine should be negative, cosine should be negative. So really, this whole list and everything, it's really not that complicated. The tangent was the only one that gets slightly confusing, and that's because tangent is dependent upon the values of sine and cosine, because we know that tangent equals sine over cosine. Right? So the tangent here is going to be positive because the sine is positive over the positive cosine, and that yields a positive. Over here, the sine is positive over the negative cosine, and that yields a negative tangent. Down here, the sine is negative over the cosine, which is negative, and a negative divided by a negative, we know, yields a positive, so tangent is positive. And then lastly, over here, sine is negative over the positive cosine, yields a negative tangent. Okay, so once we think about the sine, cosine, and tangent more in the coordinate plane, figuring out the sine values becomes a lot easier. And when we look at something like this, and I'm referencing to this triangle here, I don't necessarily have to put a negative 3. I could evaluate 4 over 5, 3 over 5, 4 over 3, and then look at my coordinate plane again and think, okay, hold on. I know that I am in quadrant 2, which tells me that the sine should be positive, which it is, that the cosine should be negative, and I can place a negative there, and that because sine is positive, cosine is negative, my tangent is negative. I can place a negative there. All right, so there's different ways to go about this. You'll figure out which one works best for you and which one is less confusing for you to hold on to. So now, I mean, we've already talked about reference angles a little bit, but let's work with them a little bit more. This first example is almost identical to the one that we were just doing. We have a large obtuse angle, and its reference angle is found by taking 180 and subtracting this value here. For example, if theta equaled 130 degrees, my reference angle over here will be found by doing 180 minus 130, and my reference angle would be the 50-degree theta value in here. Right? And I could make my triangle in here, and I'd be able to work with it just like that. Now, what about if the theta value goes beyond 180? Okay, well, it's almost the exact same idea, but instead of doing 180 minus theta, we're going to do theta minus 180. That's still going to give us basically how far it goes past 180 degrees to give us the reference angle. Right? So if theta happened to be something like, I don't know, well, let's just say it's 200 degrees. I'm going to do 200 minus 180, and that's going to give me my reference angle of 20 degrees, which is this little piece in here. And again, I can draw my triangle, and I'd be able to work with it just like that for that angle in there, finding me the same sine, cosine, tangent values. And my last one is what happens when theta goes and it reaches all the way into the third quadrant. I'm not going to do theta minus 180 because that's still going to give me an obtuse angle. That would give me this angle. Still give me one that's too big and it's not a good reference. So now I'm working with 360 degrees. And I'm going to do 360 minus theta. So let's say that this one happens to be a 320 degree rotation. I'm going to do 360 minus 320. Hello. And I'm going to get that my reference angle is 40 degrees. So this in here is 40, and I can work with that angle in there, getting me the same sine, cosine, and tangent values. Okay, so reference angles are going to be very, very, very useful. So now let's look at how we can actually find some of these. First I have 300 degrees, next I have 2.3, and there's no degree symbol, so we're talking about radians here, and negative 135 degrees. Now the first thing to do for some of these, if you can't visually depict where it is in your mind and be able to work with it that way, is to make a picture. Okay? It's very, very important to understand that 300 degrees rotates counterclockwise all the way to here, and that 2.3 rotates into the second quadrant out to here, and that 225 rotates into the third quadrant to there. So let's look at 300 degrees first. 300 degrees brings me into the third quadrant. That means that I'm going to do a little something like this. 360 degrees minus 300 gets me my reference angle of 60 degrees. And I could make my triangle and use that reference angle to solve for sine, cosine, and tangent. Now 2.3 radians brings me into the second quadrant. Being in the second quadrant means I'm working with 180 degrees. I'm going to say 180 minus whatever amount of degrees it is, but I'm in radians. So facing a little bit of a dilemma here. Instead of 180, I'm just going to use the radian value that is 180. And we know that that's pi. Pi minus 2.3, and that is going to get me the radian value that I need for this particular one, which is about 0.8, 0.4 radians. And lastly, 225. Now 225 goes beyond 180, but not so far that it's in the fourth quadrant. It's still in the third quadrant. So what is it that I do when it goes past? I do not 180 minus theta. I do theta, which is 225, minus 180. And what does that get me? I do 225 minus 180, that gets me about 45 degrees, and that's right in here. I could draw my triangle, and I could find sine, cosine, and tangent. This table right here gives you some of the most common angle measures: 0, 30, 45, 60, 90, 80, 270. It will be something that you will be quizzed on because it's really important that these angle measures are quick to come out of your mind. So this table will be very important. And lastly, trigonometric functions of non-acute angles. So what we're going to do here is basically evaluate these trig functions But the difference between these and ones that we've done before is that they're larger. They're ones that we have to find a reference angle for and then be able to work with them. So the first thing, just like I said on the last one, I think is going to be to draw a picture. So I am going, for part A, do a little coordinate plane. And let's see, where is my thing going to end up? 4 pi over 3. 4 pi over 3 I know is something like 3 pi over 3 plus another pi over 3, because that would be 4 of them. So I know that 3 pi over 3 is essentially just pi. So I know it rotates this much, and then plus another pi over 3 rotation. So this is about what I'm looking at here. So what is my reference angle? It's gone past 180 degrees. Well, we're in radians, so it's gone past pi, which means I'm going to be doing a formula that looks like 4 pi over 3 minus pi. And pretty much what I did up here was I split 4 pi over 3 into pi plus pi over 3. Now when I do pi plus pi over 3 minus pi, I'm just left with pi over 3. So my reference angle in here was pi over 3. So what is the cosine of pi over 3? Well, if I look to that trusty little unit circle in the beginning of the book, or if I look back possibly into here, the cosine of pi over 3, or 60 degrees, was supposed to be 1/2. Am I done? No, because I also need to think to myself, pi over 3 is only the reference angle. It's not the actual angle. Where is cosine? Like, what is the sign of cosine in this quadrant? Well, cosine relates to the x values. X values are positive on the right, negative on the left. So this should evaluate to a negative 1/2. And that should be my answer for part A. Part B, do I have extra side? Yes, I do! 210, and we're in degrees. Alrighty, so first things first, let's figure out where is negative 210 degrees. Negative means that I'm rotating downward, down and to the left, and I know that it's at least 180 degrees, so I know I'm going at least that far. And then past there, it's about 30 degrees past, which kind of gives away what the reference angle is, because I know that I went 180 and I went 30 degrees past. My reference angle in here is 30 degrees. 30 degree reference angle in there. Alrighty, so I'm looking for the tangent of 30 degrees. What is the tangent of 30 degrees? Let's see, do I have that on my trusty little thing over here? 30 degrees, tangent, square root of 3 over 3. So is that good enough? Square root of 3 over 3. No, I need to think. 30 degrees is only my reference angle. I'm in quadrant 2. What is the tangent in quadrant 2? Is it positive or negative? Well, I know that the sine is positive because it's above the axis. I know that the cosine is negative because it's to the left of the y-axis. So that means that if sine is positive, cosine is negative, tangent must be negative. So this should be negative square root of 3 over 3. And the last one, where is 11 pi over 4? This one might be a little bit trickier because it goes on a full rotation. If I were to break this up, I would probably break it up so it said 8 pi over 4 plus 3 pi over 4. That way, this is 2 pi. That's the full rotation. And plus 3 pi over 4. So I know that this is going to go whoop, all the way around, one full rotation, and then I'm going to add 3 pi over 4, which basically is going to go to about there. So this is what I'm looking at here. Now, the question is, how far did I go? What is my reference angle? I can kind of neglect this part because it really didn't matter. It just rotated the entire thing around once, and that's not a big deal. I'm really only caring about 3 pi over 4. Now, it's in the second quadrant, which means I'm going to do pi, which is right here, minus 3 pi over 4, and that's going to get me my reference angle. Okay, when I do that, what I'm left with is pi over 4, my reference angle in here, which is a 45-degree angle. So I'm doing cosecant of pi over 4. This is the bar where it usually gets easy, but now I have a cosecant here, which I really don't feel too comfortable evaluating. So all we need to remember here is that cosecant relates to the sine, right? If I can figure out what the sine of pi over 4 is, I can just take the reciprocal and that'll be my cosecant. So what is the sine of pi over 4? Well, if I look back, let's see, that should be on my handy-dandy chart. Pi over 4, 45 degrees, sine of it, square root of 2 over 2. Okay, so sine pi over 4, square root of 2 over 2. So, if I want the cosecant of pi over 4, that should just be the reciprocal, 2 over the square root of 2. Which, if I want to make take the radical out of the denominator, is just going to equal the square root of 2. Very good. Now, am I done? No, I need to think positive or negative, because pi over 4 was just a reference angle. I am in the second quadrant. I'm looking at things to do with the sine. So is the sine positive or negative in the second quadrant? Well, it's above the x-axis, which means it's positive, which means I am done positive square root of 2. Fantastic! All right, do the assigned exercises. I will see y'all in class. I'm going to go back to my marathon. See you later.